In this lesson, we are going to practice implementing more different commands, creating functions, and even sending messages from inside the contract. We're going to do all of this on top of the existing contract we already have. So what's our plan? Let's break it down. First, our contract will become more strict on commands. We are going to introduce a new operation code meant for the logic of depositing funds to the contract. Another opcode we are going to introduce is withdrawal of funds. During the withdrawal process, the funds are actually sent to the address as a message, so we will learn how to send messages from within the contract. Any funds that arrive with unknown operation codes, they will be returned to the sender, simply bounced. And we will also introduce new value in our storage, owner of the contract. Only owner of the contract is able to withdraw funds. We will also separate the storage loading and writing logic into the storage into the separate functions, so our code would be more clean. So are you ready? Set, go. So first of all, let's deal with the contract's owner's data in storage. So we will create a new address in the storage, but also, as you can see here, we're operating with the system functions like set data and get data like inline inside of the logic code, but we want to separate them into functions. And to do so, we will create two functions. One is going to be called load data, and another one is going to be called save data. So basically, we will kind of like encapsulate this logic of interacting with the storage. So you can see that our load data is having a new specifier. So you remember that we were talking about the specifiers, that there's a number of them. So let's understand what it is. So you already know a little bit about a specifier that we had, like method ID, yes? But if a function has an inline specifier, its code is actually substituted in every place where this function is called. So basically, when the code gets compiled into assembly code, so these commands that are already compiled, they will be, the whole piece of code will be put in every place where this function is called. Why the load data doesn't have the impure specifier? Because it doesn't affect the state. And as you remember, if the function doesn't have impure specifier and its results are not used anywhere, then it's going to be simply removed during optimization. So we actually want to not specify it here because we are using the results. We are using the results of the function that it returns. What we do here is we are opening, first we get the cell of the storage. We begin parsing this cell, and then we start to read it out. So we read 32 bits, then it goes further. It reads the message address of the most recent sender, and then we are reading one more address, the address of owner. And this is how you are going to do logic in contracts, that you suppose something, so you know that in future you will initiate the contract with 3 values, and that's how you write the reading of it. And now let's move to the save data. So basically, function save data, it is impure because it affects the state. It is using the set data function. So, and it is also inline, so it will be put every time save data is called. In assembly code, the code is going to be put in places of where it's called. So we call the function set data, and we run a builder here. We store the integer that is coming here into the function. We store slice that is, we also get in here the recent sender, and then same with the owner address. So it is now as simple as that. So now we are going to actually use these functions here. So for example, first we would need to read out the variables from the storage. So we just call function load data. We don't need to pass anything into it. We just get values that it returns. So we have counter value, we have recent sender, we have owner address, and obviously these are now variables. We know their types because they're specified here. And what we need to do now is, once we get the operation 1, we should actually, so we counter value we already know from here. So this part we can easily remove. This one we read from message. And basically, everything we need to do is we need to call this function save data. We need to call it and pass the values just like this. Counter value plus increment by, sender address, and the owner address. As you can see, we cannot just put, if we, for example, if we didn't change the owner address, we cannot just put it like this because cells are immutable. If you are constructing a new cell, you're actually replacing the old cell with a new one. So we would have to make sure that all the data that we want to be there, we compose it into a new cell that we save there. One thing that I wanted to do here as well is return. So basically, this is going to be a successful finish of this operation because we know that operation code is here. We read increment by. There is nothing more in functionality that we want to be there. So now let's introduce a few more operation codes. So it is going to be something like this. So for now, they're just empty. So this is how we use comments. So deposit, operation code 2 will be for depositing funds. Operation code 3 will be for withdrawal. And if we don't know this code that comes, we'll just throw an error with, let's say, 3/7. But one important thing before we actually go into this logic, let me update the get contract storage data so it would also load. So this getter method would also return the owner address. So get contract storage data, we would expect it to also return an owner address. But again, we could just simply use the same function we're using here because now we encapsulated this logic. And now we can do counter value, recent sender, owner address. We just return it as simple as this. Also important to note this 777 code. It's just a number that I came up with, but you can go into the documentation and you can check the official error codes. But basically, any exit code that is higher than 1 is considered to be an error code. So this will be error code and it will basically bounce the message if the contract has enough funds to actually send it back. And this will happen under the hood. You don't need to worry about it. Let's move to more operation codes, deposit. It's quite easy with deposit because when money arrives, we would just want to do a return and say that everything's fine. We just accepted funds. So basically, the deposit is done now. What about the withdrawal? With withdrawal, it is just a little bit more complicated. So we have to compare the sender address to the owner address of a smart contract. And let's see what are the things we need to know in order to implement this logic. So one, we need to understand how to actually compare the values. So we will use the standard function equal slice beats. It's just something that, let's just put it here under comment. So we'll need this function. And then we will learn some concept that is about throwing the errors. So there's two types of throwing the errors. There's throw unless, and then there's throw if. So we will go into details when we will implement this code. So their logic just works different. So in one case, you will throw the error if the condition is not met, and in another case, you will actually throw the error if the condition is actually met. The message body with this operation would actually require to also have an integer that is stating the amount requested to withdraw. And we compare this amount to the actual balance of contract, and we are able to get the actual balance of contract with a standard function getBalance. One second. So this is just outlining some functions that we're going to use here. And we want our contract to always have some funds. So you would be able to pay rent and other necessary fees that you learned about in the first few chapters. So we would need to set some minimum that would have to stay on the contract and throw an error if the requested amount is not allowed to be withdrawn. And finally, we need to learn how we can send coins from inside the contract via an internal message. So let's see how this all would work together. So let's first start with the certain amount of tons that we always want to keep. And we have to define this amount somewhere in the beginning. So basically, we would want to keep 0.01 ton for the minimum tons for storage. So this will be a constant. We were going to check if there's enough amount left. Let's now get back to this withdrawal logic. So here you can see how we're doing throw unless. So we are going to throw an error code 103. Again, this is the code number that I came up with. When I'm going to write tests, I would expect this code to be thrown if I initiate a transaction from the address other than owner address. So if I'm requesting withdrawal from other address than owner address. And then I'm going to read the withdrawal amount. So this is in message body, you remember. So we can collapse this one, we can collapse this one, we don't need it. But here we know that we read the operation code from the in-message body. So know that next after these 32 bits, there's going to be the amount, how much to withdraw. So when we set the amount, for example, the operation codes, we are doing load uint. But when we set amount of coins, when we need some numbers, let's set the amount of coins, we also get an integer here, but we would actually need to load coins because we know that here there's a specific maximum of bits that are always dedicated for this. So we read them out. Once we are going to compose this transaction, we will also do store coins. So coins has a defined amount of bits dedicated for it to be stored. And here we're using this function getBalance. So we are actually getting the balance. We don't care about the second value here. You can read about it in documentation. And here we just use getBalance, and this is going to be integer. So another error we're going to throw here is 104. Again, this is our notation, our error codes. So we are going to throw this error unless the balance is actually bigger or equal than withdrawal amount. And lastly, we now have the integer that would actually be the amount we request our contract to send to the owner of the contract. So basically, we want to make sure that we keep the funds on the contract. And this is why there's an interesting technique that you can use here. So we compare what is less, the requested withdrawal amount or the balance minus this amount that should be always stay on the contract. So you don't want to take more than would be allowed to keep the requested amount on the contract. And at this point, we are, if ever, like here, we are going to do the sending internal message logic. And then we just do return. Great, so the last thing we need to do is actually to send internal message. So let's talk about this. So sending internal message is done with a function called sendRowMessage. And we're going to learn a lot about it now. So basically, function sendRowMessage is accepting the cell with message and an integer that is containing sum of mode and flag. So this is getting a little bit more complicated. Don't get confused with it. And let me open the documentation, and this will be a good example for you how you can learn about certain standard functions from the documentation. You can see I'm on the official documentation website, and I'm reading the data about sendRowMessage. So it would accept a cell with message. So as you know, we can put a lot of values into the cell just step by step. And the second parameter it would receive would be this integer that would have to define the mode. So lower, we have that there could be mode 0, just a normal message. There could be 64. So mode 64 would actually carry all the remaining value, and mode 128 would actually carry all the remaining balance of the current smart contract. There's some details with each of them, but we're going to use just a mode 0. And also there is flags. So basically, you can see that this integer that we provide here, it has to be actually sum of the modes and flags. So combination simply means getting a sum of their values. So it's combination of mode and flag. So you choose something from here, and you choose something from here. So basically, we are going to use value 1 because we want to have it ordinary message, and we want to pay transfer fees separately from the message value. So this is just a little bit of a glance for you how to actually figure out what modes you can possibly go with. And documentation is a very good place to actually learn about this. So I already showed you the documentation part where you can actually understand that there's different modes. You need to compose a cell, and then you need to choose the mode and flag. You can sum them, and you can put them into the function send_raw message. But first of all, you will need to get used to how data is stored in cells. This is called serialization. I was talking about this a little bit for some time, but this is called serialization. And at this moment, you will need to get familiar and used to this, as you will be serializing data into cells quite often, as everything is stored in cells. And another thing that you will really need to get comfortable with is TON documentation. And that's pretty much the only way to get around with all those serialization structures, and it's extremely hard to remember them. You will probably use documentation as a go-to tool for your discoveries. Now we will need to break down the structure of the message, of the serialized message, of this message that is stored in this cell. So we are going to pass it into the send_raw message, and as you already understood, we need to put a number of bits into a cell, and there's a certain logic which bit is responsible for what. Next, we are going to actually work with the actual cell that we need to compose with the message. And to get better around it, let's go into documentation too. I'm going to provide the links to this documentation part in the attachment to this lesson. And let me show you the documentation part that I'm talking about. I'm right now at the documentation page, which will tell us a little bit more about this serialization rules for the message cell, because this is very important. You will send messages quite a lot from FunC, from the inside of the contract. And you see what documentation states, that the message starts with 1-bit prefix 0. So we get it here. And then there is 3 1-bit flags. So flag that the hypercube routing is disabled, currently is always true. This feature is not supported yet. The message should be bounced, like allow bounces. And then we do it's not a bounce itself. So basically, you see we dedicate 1 bit. So all 4 things in the beginning are basically flags. So 1 about the internal message, and then these 3. And then we serialize actually the addresses. So this is the source address, and this is destination address. Then we store coins. So we basically serialize the currency collection. So we store coins, and we say the amount of value, that the money that are actually in there. Next, we store dictionary with extra currencies. This feature is not supported in the moment. We store some fees. We are not going to use most of them. And some of them, furthermore, as the documentation states, that some of these values will be rewritten. So that means that once we're composing this cell, we can just put any dummy value there, because validator is responsible for putting the right thing there. So once this cell is going to arrive to another contract to be parsed, to be read from it, actually the values will change, because validator is basically responsible for writing values like time of transaction and stuff. So here you can see that validator will rewrite if it's bounced or not, the source, it will confirm the source. So because you can do some fake source, but validator will just rewrite who actually was the sender, and etc. So these values will possibly will 100% be actually rewritten. But again, in documentation, we can see that this is quite a big composition of message. And bad part of it is that half of the values are either not supported yet, or these values are just rewritten by validators. So that's why we have a shortcut. So we would have a shortcut that is actually allowing us to skip setting some values that are not even used. So first of all, we have this 0x18. So this is a value that is stored in 6 bits. So it's just basically representation. So the first bit, 1 bit prefix. Then there is 3 bits, 110, meaning that this IHR is disabled, messages can be bounced, and message is not the result of bouncing itself. So basically, we just use, before the sender, we write like same thing that like the shortest valid address that we can put is like 00. So like basically, we provide all these values all together as such a sequence of bits, and it's actually could be represented by a hexadecimal number like this. As I said, don't get confused about this. We are actually going to do this quite a lot, like that you're going to compose these cells, and here, instead of just writing bits one by one, you would put just a shortcut of the most common message that cannot that can be bounced and that is not bounced itself, so it was composed. And basically, you would just use these shortcuts of 6 bits because you don't want to go through this and this source address shortcut. So you just want to remember that this is the representation of the most common message used. However, if you want to do some more complex message, that cannot be bounced, for example, yes, you know what to do. You can just compose it manually, bit by bit. And then if you use a shortcut, you would actually store the address. It would be already destination because, as you remember, the source we used as, here you can see, the address none, because it's serialized like just 2 bits, 00. Okay, so another thing, we store coins. Next, we store coins. And you can see, yes, so basically store uint is the optimized way of serializing the tag and the first 4 fields. So next we serialize the destination address, and then we should serialize the values and like the currency collection itself. This means like some extra currencies that are we can just ignore for now. And there is more values. There is more values so extra currency dictionary. So then we just store these fees also that are going to be overwritten, and we'll just put zeros into this created at. And basically, we would just replace all these values with just zeros, just a lot of zeros. And you can see that here. So after storing grams, we just put a 0. And here we put how many bits we actually dedicate on it. So just going one more time. So extra currencies, here in documentation, you can see that first bit stands empty extra currencies dictionary. So there is no dictionary. So that's why we put 1. And then we do 4 bits for these fees and 4 bits for, yes, we actually do twice 4 bits. So 1 fee and another fee. So we have 4. And then we have 64-bit long for created LT and 32-bit long strings, because these are going to be written by the validator. And then we say that there is no init field, for example. This message is not going to create init state for some contract, because you remember that you deploy contracts by sending messages. So you could easily deploy a contract by sending a message from inside another contract. So, but you would have to provide it with initial state, right? Just like we did on deploy. And we just state here that there is no init field. And the last 0 that we put here, it means that message body will be serialized in place. So basically, if we don't put it there, then we just have a message body. The rest of the cell would be just a message body. So again, this might seem complicated, but as you can see, there are some shortcuts. But as I was saying in the beginning, you should learn this idea of serialization, and you should get this very clean concept of memory layout, that the layout is cells, and the cells can be stored bit by bit. They could be filled with some information. And the only way to keep up with what kind of information you can put in there is to read documentation, because basically these cells are going to be then certainly treated by the validator, by other people's contracts, and you would need to actually get this concept and practice with it quite a lot. So let's see how this applies to our funds. So we basically are going to compose our own cell. So we will use a builder, begin cell. Then we will use this shortcut 0x18 with flags and the empty source address. Then we'll store the destination address, because as this sender is requesting us to withdraw his funds to his address, we compare that he is an owner and we put him as a destination here. And then we put the coins, how much money we want to send. Just this value that we actually we calculated here, and we put it into the proper place inside of this cell. And then we would just put this amount of zeros. So we just put it 1 plus 4 plus 4 plus 64, just out of usability, so you would understand that you could potentially just not using zeros. You could potentially create a proper structure of the cell if you want to do very complex functionality. But as you can see, these last two, for example, mean that there is no init state and then there's no body. If we would remove them, we would actually have to put the init state and the body inside of the very same cell. But for the withdrawal, we don't really need body. And it's not going to deploy other contracts, so this message is going to be as simple as we just wrote. So we do call function sendRawMessage, and we call the end cell on this message builder. So we finalize this cell, we put it there, and we also provide the message mode. So the message mode, as I was stating before, we need to define it. Let me do it here. So the message mode will be 1. So 0 because it's ordinary message, plus 1 because we want to pay transfer fees separately. So this is mode, this is flag. I've shown you in documentation. You will have the link to documentation, and you can read more about this there. And you can always use it as a go-to place to figure out if you forgot something. So one last thing we want to do is another getter method that is going to actually return the current balance of the contract, because we will need this once we're going to test the contract. So for example, we are going to send some funds into the contract, and then we want to check that they arrived there by calling this method and comparing it to the amount of funds that we sent. So basically, this is our final code. We could remove certain comments that we just had in the process. But all in all, this is supposed to work. Let me run yarn compile. And I would expect our contract to be compiled now, but there is an error. Okay, I'm using a wrong function here. Equal slice beats, as we discussed. Yes. So, yeah, I just did a typo here. Actually, it was the old name of function. And voila, our contract is compiled. And I hope you didn't get too confused about this composing message. I was just wondering that I wanted to bring you the better understanding of the landscape, so you would be equipped for learning by yourself too, because this is a very important concept of composing these cells according to the documentation that you can read. So I'm going to see you in the next lesson, where we're going to write tests for this contract. See you soon.